So what we're showing today at DesignCon is we have a scalable vector network analyzer based on a PXI chassis, and you can have anywhere from 2 ports up to 16 ports in this chassis, or a double wide chassis up to 32 ports. What this allows you to do as an electrical engineer is to design servers and internet infrastructure with the ultimate in precision, because we can calibrate this system up to the reference plane up to 57 gigahertz. So what we're looking at here happens to be a mezzanine connector made by a company called Samtech, and this is a very small connector with a very small footprint, and the smaller the devices under test become, the more difficult it is to analyze in different domains. So what we've done here is we have special calibration software, and then after the S parameter data is taken, we can actually do a fast Fourier transform or inverse fast Fourier transform and look at both frequency domain, like insertion loss and return loss, but also in time domain, we can look at the impedance profile, where we see the actual connector under test in the middle and then 2 transmission lines on either side. And if you look down here, the connector is this backside here connecting these 2 cards, and the transmission line is on either of these cards here. So one of the main figures of merit for high-speed digital design is called the eye diagram. And what's interesting here is at these data rates, 112 gigabits per second, we actually use what's called 56 gigabaud PAM4. This modulation technique, pulse amplitude modulation, gives us 3 eye diagrams, and so we can measure each of these eyes separately to make sure they're open, so the receiver sees all of the information they need to with the lowest bit errors. So, in summary, we have a hardware system that's the first scalable vector network analyzer running with both physical layer test system software and also a firmware native VNA option TDR that's running in the black here. And so you can really have a choice of how you want to view the data, and the best way really is to do multi-domain analysis. Whether you're a digital guy or a microwave guy, you want to be able to look at both time domain and frequency domain.